my screen is visible to you people?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, so today's discussion is related with assignment problem, or rather assignment model, as we are discussing the mathematical structure and converting every problem into a model and then solving it. So the most or all of the problems of OR are also called as models. Okay. So assignment means we are supposed to make the assignment here. In transportation pro model, what we are doing, we are assigning the resources to the destinations where the demand is there, so that the rim condition will be satisfied and our purpose will be failed, and that is required to be done in an optimal way for optimization purpose. Similarly, in assignment, there are number of resources generally called as labors, workers, etc., required to be assigned the activities or jobs. Okay, so and one-to-one assignment is there. That means labor will be assigned to a particular job, or job is assigned to the labor so that it will perform. What is required to be done is that based on the skill of the labor, based on the skill of the worker, the efficiency or effectiveness will vary, which will be calculated in terms of cost or time or profit or related things. And that is known to us in terms of CIG values. Okay. And then we have to make one-to-one assignment. So there is a little bit difference between assignment and transportation problem. So assignment is a special case of transportation problem. Okay, and that's what we are doing here. Um, is a particular case of transportation problem where the resources, also called as facilities, are nothing but the assignees, and the destinations are activities called as jobs. Given n resources or facilities, n activities or jobs with effectiveness in terms of cost, profit, time, etc., of each resource for each activity, then the problem becomes to assign or allocate each resource to only one activity or job, or vice versa, so that the given measure of effectiveness is optimized. That is called as assignment problem. Here, n number of activities are there and n number of jobs are there. N number of workers are there. Okay, so resources are n number, destinations are also n number. So it is a square matrix. That is one difference from transportation problem. So here the problem is assignment arises because of the resources that are available, such as men, machines, etc., are having varying degree of efficiency for performing the different activities. Because of that, this kind of problems arises, and therefore the cost, profit, or time of the performing different activities is also different by different workers. So the problem becomes, how should the assignments be made in order to optimize the given objective? So there are certain examples of this kind of assignment problems. Workers to assign machines, salesmen to different sales areas, clerk to various checkout counters, classes to the rooms, vehicles to the routes, contracts to the bidders. Kind of examples are coming under the assignment problem. So there is a mathematical model of this assignment model or problem that is required to be understood. So mathematical structure or mathematical model, what we call it as mathematical structure or model. So how it is represented mathematically, that is required to be understood, and based on that you can understand the problem very well. Okay, so similarly matrix is required. Here it is a square matrix. So what is there? Here there are workers. Okay, here workers or resources, they are nothing but the resources. Say W1, W2, and so on up to Wn. Okay, so and then there are activities. So these resources are equivalent to the supply centers in case of transportation problem, and these activities, also called as jobs, are equivalent to the destination centers. So jobs we can call it as J1, J2 up to Jn. Okay, and then there is a supply and demand. Okay, now if suppose worker or resource W1 is assigned to the job J1 or job J1 is assigned to worker W1, the cost is C11. Similarly, J2 is assigned to W2, then cost will be C12 and so on up to C1N. Okay, similarly, this will be two C21, C22 up to C2N, and this will be C1, CN1, CN2 up to CNN. Okay, and here the supply is 1 because 1 to 1 assignment we are doing. Supply is 1. Similarly, it will be 1. Okay, here the demand will be 1, 1 up to 1, and the total is nothing but N. So this is the matrix for assignment problem. Are you getting this? That means once the job, say J2 is assigned to worker W1, it cannot be assigned to any other worker. Similarly, once the W1 is assigned to J2, W1 is not free available for any other assignment. So supply is 1 and double demand is 1. Are you getting this table? Are you getting this table? Yes or no?
Yes.
Okay. Now we have to write the objective function. So our objective is to minimize or maximize or optimize. Say minimize or maximize. Z is equal to summation Cij Xij 2 times summation rather. I runs from 1 to n and j runs from 1 to n. So number of rows are n, number of columns are also n. Subject to the constraints. Here what we are going to do, we are going to assign Xij. This is nothing but our decision. Okay, Xij is nothing but our decision. And what are our constraints? What are our constraints? Can you tell me what should be our constraints? By observing this table, can you tell me what should be our constraints? So whether there are resource constraints, do you agree with me?
Yes, sir.
Whether there are demand constraints, means activity constraints, yes or no? So if suppose Xij is our decision, then our decision involves xij is either equal to 1 or equal to 0. When it will be 1? It will be 1 when resource I is assigned to job or activity J. It will be 1. Then it will be 0 otherwise. Means when there is no assignment. Okay. And constraints will be subject to the constraints. First constraint is related to the supply. That means summation xij will be equal to 1 for j runs from 1 to n for all i's 1 to n. This is nothing but resource constraint. Second is summation xij, I runs from 1 to n is equal to 1 where j runs from 1 to n. This is the resource constraint and this is our problem. Okay. And what about xij? Xij will be, another constraint will be xij will be either equal to 1 or 0 for for all I and j's. Are you getting this? Are you getting this structure? Yes or no? Either yes or no, or sometime little bit you are getting, or partially you are getting.
Yes, sir.
Yes, sir.
Okay. So previously this one was not there. Here y is equal to 1 because 1 to 1 assignment is there. Now while solving the problem, you will get this structure exactly. Okay. Okay. So I will first show the algorithm how to solve this problem and then we will discuss about. Okay, so this is the flow chart for solving this problem. Now whatever data is given to you, you have to convert it into matrix form. Matrix form means what? Matrix form means what? Can you tell me? Which we have already done in transportation problem. So I am asking you. Convert the problem into matrix form means you have to take resources either row wise or column wise, and then destinations or jobs either row wise or column wise, and then writing it along with its cost matrix is nothing but writing it into matrix form. Is it clear to you? Is it clear?
Yes, sir.
Okay.
Yes, yes.
Then see that whether it is maximization problem or minimization problem. If it is maximization, convert it into minimization. How to convert it into minimization? By subtracting all the values in the matrix from the largest value of the matrix. Is it okay? So that's what we have already done in transportation also, no? Transportation मध्ये कसं करतो कन्वर्जन? मॅक्सिमायझेशनचं मिनिमायझेशनला. How we convert the maximization problem into minimization in transportation model?
Same way, sir.
Same way, okay. Then after that, see that whether it is balanced problem or not unbalanced problem. Balance means number of rows is equal to number of columns. Number of rows is equal to number of columns. If it is the case, then it is balanced assignment problem. If it is not the case, then add the dummy row or dummy column and then make it balanced and then go further. Now what we do in the transportation problem, whether we check the balance condition before maximization minimization or after maximization minimization.
Before, sir.
Before. इथं नंतर चेक करतोय हे तुम्हाला लक्षात ठेवावं लागेल. ठीक आहे. In transportation we check that whether it is maximization or balanced or not before checking the maximization or minimization condition. Here we first check whether it is maximization or not. If it is so, convert it into minimization. If it is minimization, then go ahead. Check that whether it is balanced or not. Checking the balancing condition is different in assignment problem. number of rows must be equal to number of columns. What is the condition in transportation problem?
Demand equals supply.
That means rim condition. Checking the rim condition is checking the balancing condition. Okay. Here it is not like that. Here it is checking the number of rows is equal to number of columns or not. Is called as balancing condition. If not, then make it balanced and go ahead. Now we have to check, find the opportunity cost. How to find out that? For that you have to do identify the smallest number in each row and subtract it from every element of that row. Each row, that is important, and subtract it. Then in the reduced matrix, repeat the procedure column wise. Identify the smallest number in the column and then subtract it from that particular column in the reduced matrix. How to do that, you will come to know while solving the problem. Then next step is make the assignments row wise that have only one zero and eliminate the row and column once the assignment is made. Okay. Then repeat the same process column wise and check that is the number of assignments equal to the number of rows or columns. If number of assignments equal to number of rows or number of columns, then it is the optimal solution and consider it as optimal solution and stop the algorithm. If it is not, then improve the solution or revise the opportunity cost table. How to revise it? Draw the minimum number of possible lines on columns and or rows such that all the zeros will get covered. We will see how to cover it. Then choose the smallest number not covered by the lines, subtract it from itself and every other uncovered number. Add this number at the intersection of any two lines and do nothing with other elements on the lines. How to do that, we will see with the problem. And then again come to the make the assignment row wise and column wise block and repeat the process iteratively so that you will get the problem solved. Okay, so how to do that? We will take one problem. Let us take this problem. Take down this. Okay, there are n number of ways or methods to solve. There is one method called as Hungarian assignment method which we are going to use. Which is the method? Hungarian assignment method. Okay, a Hungarian mathematician has developed this method, so it is called as Hungarian method. Hungarian assignment method. So this is also abbreviated as HAM. HAM. Previously it was WAM in case of transportation. Here it is HAM, HAM. Okay, so that method we are going to use. Now take down this problem. Suppose there are four supplies S1, S2, S3, S4 and four destinations T1, T2, T3, T4 where we want to make the assignments. Okay, so you just take down this problem. What is the problem? S1, S2, S3, S4. T1, T2, T3, T4. What are the values given? 45, 40, 51, 67. 45, 40, 51, 67. 57, 42, 63, 55. 57, 42, 63, 55. $63, $55. And what is the next row?
49, 52.
Tell me, 49,
52, 48, 64.
What is the next?
41, 41, 45, 60. सर लास्ट टाइम दिसलं नाही आहे, चेक करा एकदा.
55. Okay, now what is the first step? First step is to identify. First step is to identify smallest element in each row and subtract that from that particular row. Can you do this as a first step? What is the smallest element in the first row?
40.
But subtract it from every element and write down. Am I right? Yes or no? First row is clear to you? अरे काय तर बोला.
Yes, sir.
Yes, sir.
What is the smallest element in second row?
42.
Okay, subtract it from all other elements of that particular row. Is it okay? Okay, next. What is the smallest element in third row?
40.
Is it okay? What is the smallest element in fourth row?
41.
Okay, subtract that from every element of that particular row. ही स्टेप झाली का कंप्लीट सगळ्यांची? Yes or no?
Yes, sir.
Okay. Then next, repeat this column wise. आता ह्या reduced matrix मध्ये म्हणजे दुसऱ्या मॅट्रिक्स मध्ये स्मॉलेस्ट एलिमेंट कुठला आहे तो त्या पर्टिक्युलर एलिमेंट मधून वजा करायचा. जर 0 असेल तर 0 स्मॉलेस्ट एलिमेंट अँड अगेन राईट द मॅट्रिक्स. सो you can write it here. Okay, so can you tell me the column wise elements after subtracting smallest element from each column? Can you tell me that? In first column it will remain as it is 5, 15, 1, 0. Am I right?
Yes, sir.
Yes, sir.
5, 15.
15, 1, 0.
Tell me about second.
Sir, same. 0, 0, 4, 4.
0, 0,
4, 4.
4, 4. Okay. What is next?
Sir, same. 11, 21.
11, 21,
0, 19.
0, 19. Okay, next. Next सांगा.
14 0 14
14,
0,
0 5 1
5. ओके, इथपर्यंत सगळ्यांच्या लक्षात आलं स्टेप्स? इथपर्यंत लक्षात आलं का?
Yes, sir.
Okay, so should we go ahead? Okay, so now the next step is observe the table column row wise from top to bottom. Okay, go to first row. If at all only 1 0 is there, make the assignment there. Making the assignment means marking it by square.
सर 14,031 आहे.
सर ते 3-1 येते सर.
P1 येते.
अरे काय तुम्ही छोट्या छोट्या बेरजा आणि वजाबाकी जर चुका लागला तर मी काय लिहायचं सांगू. आता 3 तर बरोबर आहे का?
हो हो सर बरोबर
Yes,
आहे.
sir.
ठीक आहे. का मी बघू एकदा?
नको नको सर.
ठीक आहे, ओके. So first row, observe the next step is observe the matrix row wise from top to bottom. First row, if at all only 1 0 is there in that row, make the assignment. Making the assignment means marking it by square and cross out all other zeros in the corresponding column. Okay, now second column, in while observing the first row, second column assignment is made. So all other zeros from that particular I have crossed out. Okay, then go to the second. See that whether there are only 2 zeros or only 1 0 or not. There are two, one, though one get crossed, there are 2. So for the time being, we will not make the assignment. Go to the next row. Third row, only 1 0 is there. Make the assignment. Cross out all other zeros if at all they are present in that column. No 0 is there in the third column. So no crossing. Then go to the fourth row. Only 1 0 is there. So make the assignment. Cross out if at all any other 0 is there in that particular column. Then repeat the process column wise. So first column, all the zeros are either assigned or crossed. Second column, 0 is assigned or crossed. Third column, 0 is assigned or crossed. Fourth column, only 1 0 is present. So you can make the assignment. Cross out the 0 which is there in that particular row. Now repeat the process row wise and column wise till all the zeros get either assigned or crossed. Okay. Have you understood this step?
Yes, sir.
Okay. Now see that how many number of assignments are there? How many number of assignments?
4.
4. How many number of columns or rows are there? How many number of columns or rows are there? 4. So if at all
4.
number of assignment is equal to number of rows or columns, this is called as optimal solution. This is called as optimal solution. And what will be the values? The S1 will be allocated to T2. S2 will be assigned to T4. S3 will be assigned to T3. And S4 will be assigned to T4. What is the optimum assignment cost? It will be taken from the original matrix. So 40 what is the value at 2-4 cell?
55.
55. Then 3 cell?
48.
48. Okay, what is the value at 4-1?
41.
What is the total?
$184.
184.
So 184 is the say cost or whatever it may be. Okay, suppose it is CIJ values are given in rupees, it will be cost. So it is given in say number of hours, it will be hours. And in that manner, the capacity will be evaluated and it is considered. Suppose we are considering here rupees, then this is the minimum assignment cost. Are you getting? If you make any other assignment, it will not give you this minimum value. It will be more than 184. So that will not be, though that will be feasible solution, it will not be optimal. This will be the optimal solution only. Are you getting this? Problem कसा सोडवायचा लक्षात आला? Yes or no?
Yes, sir.
Okay, सोपं आहे.
एवढ्या याच्यातच ऑप्टिमल सोल्युशन कळेल का सर?
काय ते?
या स्टेप मध्येच ऑप्टिमल सोल्युशन कळेल ना? म्हणजे याच्यात डिजनरेशन वगैरे काय नसतं ना?
या स्टेप मध्ये ऑप्टिमल सोल्युशन येईल आणि तेच ऑप्टिमल सोल्युशन आहे. Okay, now we will take one more problem. Okay, take down this problem. Suppose there are jobs A, B, C, D, E and employees 1, 2, 3, 4, 5. They are required to be assigned, and if it is given in terms of man hours, then how to reduce it? Now here jobs are given row wise and employees are given column wise. That is also acceptable. Whether you write destinations row wise, and that doesn't matter, especially in assignment problem. Why? Because it is a square matrix only. Okay. So take down this problem, and can you solve this problem?
Yes.
A, B, C, D, E, and then 1, 2, 3, 4, 5. A, B, C, D, E are the jobs given. Employees 1, 2, 3, 4, 5 are given, and man hours required to say assign job A to employee 1 is 10. To assign job A to employee 2 is 3. That way it is given, and it is required to make the assignment so that man hours will be minimized, or total time will be minimized. Take down this problem first. Okay, have you taken this? Okay, tell me the problem. Suppose jobs are there. Okay, say jobs. They are designated as A, B, C, D, and E. And employees are named as 1, 2, 3, 4, and 5. Now tell me the values in the original table. These are
10,
hmm?
10,
row wise sanga, row wise.
3, 3, 2, 8, 9, 7, 8, 2, 7, 7, 5, 6, 2, 4, 3, 5, 8, 2, 4, 9, 10, 9, 6, 10.
Okay, so hey, बरोबर आहे ना? Okay, now reduce that matrix by observing the row wise minimum element and subtracting it from that particular row. Can you do that?
Yes, sir.
Okay, complete it and tell me the values. Okay, tell me the values row wise.
The third
1, 1.
Yes.
थर्ड कॉलम सांगायचं का म्हणजे रो वाईज आणि कॉलम वाईज दाखवायचं.
थर्ड कॉलम काय?
थर्ड स्टेप रो वाईज आणि कॉलम वाईज आपण करतो ना.
अच्छा, मग नाही आधी रो वाईज सांगा ना. हा सगळंच सांगताय, ठीक आहे, काय हरकत नाही.
7 0 0
नाही, रो वाईज कॉलम वाईज करून सांगा, काय हरकत नाही.
ओके हा रो वाईज सांगतो आता.
आधी रो वाईज करा, मग कॉलम वाईज करा आणि मग मला सांगा. डायरेक्ट तिसरा टेबल सांगा.
हो सर. 7 0 0 0 4.
तिसरा सांगतोस ना?
हा डायरेक्ट
7
0 0 0 4.
ओके, नेक्स्ट.
6 4 5 0 3 4 2
येस, तिसरा रो
4 2 3 0 0 0 2 5 0 0 2 3 2 0 0
2 3
0 0.
ठीक आहे, सगळ्यांचं हे आलं. आफ्टर डुईंग रो वाईज अँड
Yes, sir. Yes, sir.
विथ कॉलम वाईज सगळ्यांचं असं आलं का?
हो सर.
हो, सर.
Yes, sir.
तर पुढचं उत्तर सगळं चुकणार आहे म्हणून विचारते. Yes, okay. So for now observe this table row wise. Okay, if at all only 1 0 is there in that row, then make the assignment. In first row, more than 1 zeros are there. In second row, only 1 0 is there. So make the assignment, cross out all other zeros from the corresponding column. Okay, then go to the third row. Only 1 0 is there. No, there are two, so one is crossed. Then fourth, there are 2 3. Then fifth, there is no zero available for marking. Okay, then do it column wise. First column, only 1 0 is there. Cross out the other zeros. Then second, cross out the other zeros from the corresponding row. Third, there is no zero available. Fourth, already assigned or crossed zeros. Fifth, only 1 0 is there, though there is one crossed. Now you can make here the assignment, or again you can evaluate row wise and see that only 1 0 is there and make the assignment. Is it okay? So repeat this step row wise as well as column wise until and unless all the zeros will either get assigned or get crossed. ठीक आहे, सगळे झिरो असाइन किंवा क्रॉस झालेले आहेत का? Yes or no?
Yes, sir.
Okay, now see that how many number of assignments are there?
4.
4. Whether number of assignments is equal to number of columns or row?
No, sir.
No.
No. So this is not the optimal solution. This is not the optimal solution. Now to find out the optimal solution, you have to go for the next step to find out the opportunity cost or opportunity improvement in the opportunity. For that, you have to draw minimum number of lines which will cover all the zeros, whether it is assigned or crossed, that doesn't matter. So all the zeros must get covered and you have to draw minimum number of lines. आता इथं मी नुसतं बघून सुद्धा लाईन काढू शकतो. पहिल्या रो मध्ये मी एक लाईन ड्रॉ केली, चौथ्या कॉलम मध्ये एक लाईन ड्रॉ केली, नंतर पाचव्या कॉलम मध्ये एक लाईन ड्रॉ केली आणि चौथ्या रो मध्ये एक लाईन ड्रॉ केली, तर सगळे 0 कव्हर होतील. बरोबर आहे. फर्स्ट रो, फोर्थ कॉलम, फिफ्थ कॉलम and fourth row. If I draw the line, all the zeros will get covered. Yes or no?
Yes, sir.
Okay. So minimum number of lines are 4. In 4 lines I have drawn it. Number of lines are lesser than number of rows or columns. Okay, sure, that should be the case. Otherwise it will become optimal solution. Okay. आता जर तुम्हाला मिनिमम नंबर ऑफ लाईन्स, आता मोठा मॅट्रिक्स असेल 6x6, 7x7 आणि तुम्हाला शक्य नसेल बाय ऑब्झर्वेशन, सो देर इज वन मेथड आय विल टेल यू. ओके, सो शुड वी गो फॉर दॅट और कॅन यू ड्रॉ द मिनिमम नंबर ऑफ लाईन्स बाय ऑब्झर्विंग इट ओनली? Should I tell you the other method, systematic method to draw the number of lines?
Yes, sir.
Okay, so let us take different color. Okay, now observe the rows. Mark the row where the assigned 0 is not there. Mark the row where assigned 0 is not there. पहिल्या रो मध्ये assigned 0 आहे का?
No.
आहे. पहिल्या रो मध्ये आहे
ना.
आहे की.
तिसरा आहे, चौथा आहे, पाचव्या मध्ये नाही आहे. सो मार्क दिस रो. ओके, mark this row. Then see that whether in that row any cross 0 is there. Whether any cross 0 is there in that row?
Yes.
Yes. Mark that particular column. Mark that particular column. See in that column whether there is any assigned 0 is there or not.
Yes, it is there.
Assigned 0 is there. Mark that particular row. In that marked row, again see that whether there is any crossed 0 is there or not. In second row, cross 0 is not there. In second row, cross 0 is not there. Am I right?
Yes, sir.
Okay. If it is there, then you have to mark that column, and again you have to see that whether there is any assigned 0 is there in that column, then mark the row. Again see that whether there is any row where the cross 0 is remaining. No. ही प्रोसेस रिपीट करायची जोपर्यंत सगळे अनमार्क्ड रो, मार्क्ड क्रॉस रोज कव्हर होत नाहीत तोपर्यंत. ठीक आहे. ओके, now we are completed the process. Now draw the line where the marked column is there. Draw the line where the marked column is there, and draw the line where unmarked row is there. All the zeros will get covered. झाले का? झाले का? अरे मी काय म्हणतोय,
Yes,
there
sir.
are various ways of drawing it. फक्त वेगवेगळ्या पद्धतीने लाईन ड्रॉ होऊ शकता, पण मिनिमम नंबर ऑफ लाईन्स and all the zeros must get covered. That is our condition. Minimum number of lines and all the zeros must get covered. Okay. तर त्याच्यासाठी सिस्टमॅटिक वे मी तुम्हाला सांगितला. परत एकदा सांगतो, रो वाईज ऑब्झर्व करा. जिथं क्रॉस 0 आहे त्या रोला मार्क करा. इथं पाचव्या रो मध्ये क्रॉस 0 आहे, त्याला मार्क केला. त्या रो मध्ये क्रॉस 0 आहे का? नाही, क्रॉस 0 नाही. रो बघा, ज्या रो मध्ये असाइनमेंट झालेली नाही, असाइन 0 नाही आहे, ती रो मार्क करा, टिक मार्क करा. त्या रो मध्ये क्रॉस 0 आहे का बघा, त्या कॉलमला टिक मार्क करा. त्या कॉलम मध्ये असाइन 0 आहे का बघा, त्या रोला टिक मार्क करा. परत त्या रो मध्ये क्रॉस 0 आहे का बघा, त्या कॉलमला टिक मार्क करा. परत त्या कॉलम मध्ये असाइन 0 आहे का बघा, त्या रोला टिक मार्क करा. ही प्रोसेस परत दुसरे अनअसाइन्ड रो साठी रिपीट करा जर असेल तर, आणि अशा पद्धतीने सगळ्या मार्किंग कंप्लीट करा. ओके, आफ्टर कंप्लीटिंग दॅट ड्रॉ द लाईन फॉर द मार्क्ड कॉलम अँड अनमार्क्ड रोज. ऑल द झिरोज विल गेट कव्हर. ठीक आहे, तेच आपण इथं केलं. काय केलं लक्षात आलं?
सर ते लास्ट काय बोलले ते मार्क रोला आणि अनमार्क रोला.
मार्क्ड कॉलमला रेश मारायची आणि अनमार्क्ड रोला टिक मार्क जिथं नाही आहे त्या रोला रेश मारायची.
ओके.
आता टिक मार्क चौथ्या कॉलम मध्ये तिथं लाईन मारली, शॉर्ट ऑन द लाईन देअर. आणि पहिल्या, तिसऱ्या आणि चौथ्या रोला टिक मार्क नाही आहे म्हणून तिथं लाईन टाकली. सगळे 0 कव्हर झाले का?
हो सर.
ओके, नाऊ नेक्स्ट जे इलेमेंट कुठल्याही लाईन वर नाही आहेत, द एलिमेंट्स दोज हू आर नॉट ऑन द लाईन, फोकस ऑन दोज एलिमेंट्स and find out the smallest element of that. What is the smallest element?
2.
Which is not on the line. Subtract it from all the elements which are not on the line and add that element to the intersection of the line where the two lines are crossing, and do nothing with the elements which are on the line only, and write down the table again. Can you do that? मी काय म्हटलं?
ओके सर. Two is the smallest element. Subtract it from all the elements which are not on the line. Okay. Add it to the elements where the crossing is there, intersection of two lines are there, and do nothing with other elements which are only present on the line. Okay, so first row 7 0 0 2 4, 7 0 0 2 4, 7 0 0 2 4. लक्षात आलं कसं आलं? सेकंड रो 4 2 3, 4 2 3, then intersection is there, 2 no intersection is there, then 0 will remain as this, 0 1 0 1. Next row 4 2 3 2 0, 4 2 3 2 0, 4 2 3 2 0. Then fourth row 0 2 5 2 0, 0 2 5 2 0, 0 2 5 2 0. Then fifth row 0 1 0 0 0, 0 1 0 0 1 0 0 0. बरोबर आहे? सगळ्यांचं असं आलं?
सर सर डाऊट होता, एक डाऊट होता सर. ते तुम्ही थर्ड रो मध्ये जी लाईन हे केली आहे ना, तर त्याच्यापेक्षा त्याच्याऐवजी जर फिफ्थ कॉलमला केलं तर आन्सर सेमच येईल का?
आन्सर बदलणार नाही, ऑप्टिमल सोल्युशन सेमच येणार. थर्ड रो मध्ये मी आता लाईन टाकले ना, त्याच्याऐवजी तुम्ही फिफ्थ कॉलमला, मी तुम्हाला सांगितलं ना, मी बाय ऑब्झर्वेशन फिफ्थ कॉलमला टाकू शकतो, ती थर्ड लाईन रोची लाईन निघून जाईल, तरी सुद्धा काही फरक पडणार नाही. एलिमेंट्स पुढच्या मॅट्रिक्स मधले चेंज होत जातील, पण ऑप्टिमल सोल्युशन सेम येणार आहे. सोल्युशन बदलणार नाही, नॉट ॲट ऑल. देर आर व्हेरियस वेज ऑफ ड्रॉइंग द लाईन्स.
तुम्ही कुठल्याही पद्धतीनं काढलं तरी चालेल, फक्त मिनिमम नंबर ऑफ लाईन्स आणि सगळे झिरो कव्हर झाले पाहिजेत. पण मी आता जे सांगतोय तेच करायचं पुढच्या इम्प्रुव्हमेंटसाठी किंवा अपॉर्च्युनिटी फाइंड आउट करण्यासाठी, इम्प्रुव्हमेंटसाठी. आणि अल्टिमेटली यू विल रीच टू द ऑप्टिमल सोल्युशन. यू आर बाउंड टू गेट करेक्ट सोल्युशन, नो डाऊट अबाउट इट. ठीक आहे, डाऊट क्लिअर झाला का? तू करून बघ, तू 5th कॉलमला ड्रॉ कर, 3rd रो काढून टाक परत एकदा नंतरच्या वेळेला. हे आता सोडवूया, सोडवून झाल्यावर होमवर्क म्हणून तुम्ही सगळे करून बघा. ठीक आहे.
ओके.
सर इथे 3rd कॉलम आणि 4th रो इंटरसेक्ट ना, मग तिकडे 2 यायला पाहिजे ना सेल 3, 4 ला.
कुठं
3rd रो आणि 4th कॉलम इंटरसेक्ट होते ना ती लाईन.
3rd रो आणि
4th कॉलम.
हो, इंटरसेक्ट होते, 2 आलं पाहिजे. लिहिलं असेल ना, लिहिलंय ना 3rd रो आणि 4th कॉलम 2 आहे ना.
सर जिथे ती आहे तीच लिहायची का, जिथे अनमार्क्ड आहे ती तशीच लिहायची का?
अनमार्क बघू नका, मी काय सांगितलं, आय एम नॉट टॉक अबाउट अनमार्क फॉर इम्प्रुव्हमेंट. फक्त लाईन साठी मार्क बघायचे. लाईन
सर
साठी
तिथे 2-5 मध्ये 1 कसं काय आलं?
कुठं 2-5 मध्ये 3 - 2 is 1.
इंटरसेक्टेड नाही आहे ना.
ठीक आहे, आता मी परत रिपीट करतो, नीट आहे. मार्किंग जे टिक मार्क जे आपण केलेलं आहे ते फक्त लाईन ड्रॉ करण्यासाठी त्याचा उपयोग आहे. नाउ फॉरगेट अबाउट टिक मार्क्स, ओनली फोकस ऑन द मॅट्रिक्स. ठीक आहे, येस ऑर नो?
येस सर.
ओके, आता पुढचं मी काय सांगतो ते नीट लक्ष देऊन ऐका. जे एलिमेंट्स लाईन वर नाही आहे, द एलिमेंट्स दोज हू आर नॉट ऑन द लाईन, focus on those elements, uncovered elements, okay, and find out the minimum element, which is 2. Subtract that element from all the uncovered elements, those who are not on the line. Add that element to the intersection of the 2 lines, the cell where intersection of the 2 lines is there. Add it there and do nothing with the elements those who are present on only lines, and write down the table. That's what I have done here. बरोबर आहे का? चेक करा.
हो सर.
ठीक आहे, सगळ्यांच्या लक्षात आलं? ठीक आहे, आता नाउ मेक द असाइनमेंट ॲज युजल. ऑब्झर्व द टेबल रो वाईज, आणि जिथं एकच झिरो आहे तिथं असाइनमेंट करा. पहिल्या रो मध्ये 2 आहे, दुसऱ्यामध्ये एकच आहे. मेक द असाइनमेंट, cross out the zeros which are present in that particular column. Second, 3rd row मध्ये एकच आहे, cross out the zeros which are present on other column, that particular column. Then next row, only 1 zero is there, 2 are there, 1 is crossed, 1 is zero. So for the time being we will not make the assignment. Again, next row, 5th, there are more than 1 zero. First column more than 1. Second column, only 1 is there, cross out the zeros in particular row. Again, there are 2, 1 is crossed, another is there. Remaining 2 columns assignment is already made. Again, repeat the procedure row wise. Now here you can observe that only 1 zero is there, other is crossed 1. So make the assignment, cross out the zero which is present in that particular column. Again, go to the next row where only 1 zero is there, others are crossed. So make it and cross out all other. Repeat, see again column wise until and unless you get all the zeros either assigned or crossed. Okay, so now all the zeros are either assigned or crossed. Am I right?
Yes sir.
Okay. आणि जिथं कन्फ्युजन आहे, म्हणजे जिथं दोन zeros either are present which are not crossed or assigned, then you have to make it arbitrary. That stage we are not yet reached. Arbitrary assignment. Arbitrary assignment असेल तर मल्टिपल सोल्युशन असतात, ते नंतर सांगतो नेक्स्ट केस मध्ये. ठीक आहे, नाउ चेक दॅट वेदर आता सगळे झिरो आयदर असाइन्ड किंवा क्रॉस्ड आहेत का?
हो सर.
Okay, now how many number of zeros are there? Assignments are there?
5.
How many number of columns or rows are there?
5.
So this is optimal. This is optimal solution. Okay. And how we have made the assignment? A 2, B 4, C 5, D 1, E 3. No job is repeated, no employee is repeated. Now tell me these values in the original matrix, from the original matrix.
3, 2, 4, 3, 9.
3, 2, 4,
3,
9.
9.
Okay, so make the total. This
21.
21.
21 man hours is the answer. जर त्याला मल्टिप्लाइड बाय 110 वगैरे काय असतं तर दॅट विल बी देअर. ओके. आता या केसमध्ये सुद्धा 4च असाइनमेंट आले असते तर अगेन यू हॅव टू make draw the lines, minimum number of lines which will cover all the zeros, and then improve the solution, and that find out the opportunity for improvement, and then again make the assignments. Until and unless you get the number of assignments is equal to number of rows or column, you have to go on repeating these steps. Are you getting me? Are you getting me?
Yes, sir.
Yes, sir.
This is what is assignment problem. For next lecture, on Monday's lecture, we will take one more problem, and then we will take 2 special cases. One is multiple solution case, another is maximization problem. Okay. Then there is third case as well, prohibited assignment or restricted assignment. So these 3 cases are remaining. Most probably on Monday we will finish this topic, or if not on Monday, on Thursday we will finish it. Okay. Okay, we will stop here. Okay, so far transportation model is concerned, I already told you that you have to choose some 3 to 4 problems, solve them, upload them on the Moodle till Monday 3 PM. Okay. आज मी ते Moodle ला क्रिएट करतो लिंक. ठीक आहे. So should we stop here?